Hey guys, so these are your 13.1A notes for right triangle trigonometry. For right triangle trig, the basis of this is that it has to be a right triangle. A right triangle, we know, is a triangle that has a 90-degree angle in it. So for example, this would be a right triangle because it has a right angle in here. Now, right triangle trig only works if it's a right triangle, so if it's any other type of triangle, we can't use it. Once we have our right triangle, the opposite of the right angle is called the hypotenuse. And then from there, we've got two legs. Each one of these guys is called a leg. The things that are attached to the right angle. Okay. And recall that we know some other things about right triangles that could help us. For instance, the Pythagorean theorem only works on right triangles. So, like for instance, if I knew this leg was 3 and this leg was 4, I could use the Pythagorean theorem to help me find the hypotenuse. So, Pythagorean theorem says a squared plus b squared equals c squared. So then the a's and the b's are the legs. So this would be 3 squared plus 4 squared equals c squared. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. And then I could square root both sides and I would get that 5 is equal to c. So my hypotenuse would be 5. And I don't know if you guys remember back to geometry, but this is a special right triangle. It's a 3, 4, 5 right triangle. In any case, some other things you need to know about right triangle trig. We need to be able to identify the adjacent and the opposite sides, and that's based on an angle. So if I have a right triangle here and I pick one of these angles to be my angle A, that's the angle I'm going to focus on. The hypotenuse is always opposite the right angle, so that one's the easy one to pick out. It's also always the longest, so there would be my hypotenuse. And then with this angle as my reference, the opposite side is the side that the angle is looking at. So this would be my opposite. And then the side that it's touching, so for instance, the angle right here is sharing a line with the hypotenuse, and it's also sharing a line with this side right here. So that side that it's closest to is called the adjacent side. And it's really, really important for right triangle trig that you can identify the opposite, adjacent, and hypotenuse, because without that, you're totally screwed on these problems. So take a second. Go ahead and draw this triangle on your paper. Make that your right angle. And then let's label this one A. That'll be our angle that we're focusing on right there. Okay. Pause the video, and I want you to try to label the opposite, the adjacent, and the hypotenuse on this triangle without my help. So go ahead and pause it right now and label opposite, adjacent, and hypotenuse, and then turn the video back on and see if you got it right. Okay, so I'm going to assume that you're coming back from having it paused. The hypotenuse is the long side. So this side right here is the hypotenuse. Opposite is the one that's opposite the angle A, the one angle A is looking at. So this would be my opposite side. And adjacent is the one that's closest, so this would be my adjacent. Now, the reason we care about opposite, adjacent, and hypotenuse is that for right triangle trig, we're going to use SOHCAHTOA. And what SOHCAHTOA is a mnemonic device to help us remember which trig function goes with which sides. So here we have sine is opposite over hypotenuse. That's the SO. And then we have cosine is adjacent over hypotenuse. And we have TOA right here, which is tangent is opposite over adjacent. Okay. And we saw these in action in our activity today. So you guys had a worksheet. By the way, if you're gone, you're going to need to get this worksheet, where you had a triangle and you measured the angle, and then you were doing some ratios, and then you were finding some trig functions. And what you should have noticed is that these two tables should have come out the same. So for instance, if my angle was 45 degrees, on my calculator, I had to first go into the mode button and make sure that my mode was in degrees. So go ahead and change that on your calculator now if you weren't here today. And then I hit second quit to get out of that. And now if I hit sine of 45, right, I get 0.7, I'm going to round that up to 0.71. And what we saw when we did the rest of this table today in class is that when you measured O over H, you should have also gotten 0.71. And so what that showed us is really and truly, whether you use the triangle or whether you use your calculator, you're going to get the same value. That sine of A, and in this case it's 45 degrees, sine of 45 degrees, was really opposite of our hypotenuse. It really did work no matter what triangle we were working with. Everybody's triangles were different and it actually worked. So for your one and only example in your notes today, we're going to do more examples in notes tomorrow. If I had a triangle, for instance, let's say if I was trying to find the height of a tree, maybe the tree was too tall to measure and I wanted to know how tall it was, right? So I have a tree here. I could make a right angle. And let's say that you measured the distance from the base of the tree to where you're standing, and let's say that that was 20 feet. And then let's say you took a protractor with a straw on the end, like we're going to do here in a couple of days. We'll go outside and actually measure some angles, right? And let's say that angle came out to be 42 degrees. Okay. Well, if I want to find the height of the tree, right now, compared to this 42 degrees, this is my opposite side, and this is my adjacent side. And so what I would do if I wanted to find the height of the tree, I'm going to use the trig function that uses opposite and adjacent. So I look up here and I'm looking for the one that uses opposite and adjacent, which is tangent, TOA. So I would say the tangent of 42 degrees equals my opposite, which I don't know, so I'm going to say h, over my adjacent, which is 20. And now I have a little equation that I can solve. If I multiply both sides by 20, because multiplication cancels out division, right? These 20s cancel out, and I have h by itself. And then on my calculator, I can type in 20 tangent of 42 and hit enter, and it's going to give me the height of my tree. My tree is pretty much 18 feet. And so the thing that trig does for us that's pretty cool is it allows us to find distances like heights of objects, or distances like across a lake, or how far away a mountain is, things that we couldn't measure with a ruler, we couldn't measure with like a tape measure or anything like that, that are so far away, the only way we can do it is with an angle and one known side, which is pretty cool. Alright guys, we're going to be doing more of this in class tomorrow, so I will see you tomorrow. Thanks!